this equation, 5 minus e to the power of x over e to the power of 2x. So the first thing I do when solving this equation is I rewrite it, and I just move this up to the numerator by making the 2x a negative 2x. So then it's e to the power of negative 2x times 5 minus e to the x. And then I distribute this, right? So then I go 5 times e to the negative 2x minus e, and these exponents add together, so x plus negative 2x is negative x, alright, dx. And then what I do is I take these separately, so this right here is a constant, so this can get out, so it's 5 then e to the negative 2x dx. Now I have to separate these two right here, so plus, minus e to the negative x dx. So I'm going to solve this side first, this one. So what I do first is I set u as negative 2x. And then I know then d of x equals negative 1/2 d of u, because I find the derivative of this, which is negative 2, and then I multiply dx, and it's negative 2 dx, and then I divide du by 2 to get 1/2 du, negative 1/2 du dx. And then what I do then is I take this equation, e to the power u, right, and then and then I plug the du in for the dx right there. So then it goes negative 1/2, this is also constant, and then e to the u. And then the integral of e to the u is just e to the u times 1/2, negative 1/2, or negative e to the u over 2. And then after this I add the negative, I put in the negative 2 for the u, so then it's just negative e to the negative 2 over 2. And then I come and solve this side right here. So I make u equal to negative x, kind of like over here. And then I solve for d of x, so then d of x equals negative du, because it's just negative 1 essentially, so it doesn't really matter which one it is. And then I plug this into this equation where it's e to the power u equals then I plug in negative x for u, so then it's negative e to the power of negative x, because the integral of e to the power u is just e to the power of u. So after that, after that I just plug these back into the equation, so that's 5 times negative e to the power of negative 2x over 2. Alright, and then it is, since this is minus on the outside right here, I can just make that a plus. So that's plus e to the power of negative x. And then I simplify this further. I can make this negative 5 over 2 times, I don't need that, times e to the power of negative 2x plus e to the power of negative x. You gotta make sure we add the plus c, and that's the answer. This problem is problem 76. It tells me to evaluate the integral for b2 and then a 0, and then for the function or the equation x over the square root of 1 plus 2x squared dx. So the first thing I do is I choose my u. I'm going to choose my u to be this right here. So u equals 1 plus 2x squared. So first off, I need to find du over dx. So du over dx by using the power rule on this, because this cancels out. Using the power rule on this, 2 times 2 is 4. 2 minus 1 is 1, so 4x, right? And then, then I need to just get dx. So what I do is I make the du equal, because I multiply dx from the bottom, 4x dx. Then I divide by 4. So then it's du over 4 equals x dx. This also could equal 1/4. So that equals, well, that equals 1/4 du equals x dx, right? So that may not seem important right now, but first we need to rewrite this. So we got 2, 0, x times 1 plus 2x squared negative 1/2. And because there's an x right here, oh, dx. There's an x right there and a dx. It's just 1/4. So 1/4 times 2, 0, and then x. Whoops, don't need the x. And I look at this equation. It should only be u for this, so it'd be u to the negative 1/2 power. So u, or the square root of u over 1, right? But these right here, these won't work because I'm trying to find du. So I need to find those. So when I plug 2 in for u, when x is 2, u is 9. So u equals 9, right? And then when x is 0, u equals 1, right? So now I just rewrite that. So what you do is, for this right here, you use the power rule integral thing. So this can be rewritten as u to the negative 1/2. And then after that, you do the integral power rule. So 1/2 plus 1 is 1/2. And the denominator you put 1/2. But because there's 1/2 in the denominator, you can multiply 2 from the 1/2 and bring it up. So 2 over 1. And then after that, you can come this way more, and you do 1/4 times 2 times u to the 1/2, or also known as, instead of being 2 to the 1/2, u to the 1/2, it could be just the square root of u. Boom. Now you plug in 9, which what we got earlier right there. Here, right here, 9 and 1. So now you plug in 9 for u. So square root of 9 is 3 times 2 is 6 times 1/4 is 1.5. And then the square root of 1 is just 1 times 2, 2 times 1/4 of that. Well, you minus b, so b minus a, right? 0.5 for when you plug in 1. And that should get you your answer of 1. Alright, so for number 87, the last problem, it says evaluate the definite integral from 1 to 3 e to the power 3 over x squared dx. So the first thing I need to do is solve for u. And when I solve for u, I'm gonna choose 3 over x. So when u is 3, whoops. Whoa, I threw my pen. When u is 3 over x, I need to find the derivative, so I use the quotient rule. So x times the derivative of 3, which is just 0, minus derivative of x, 1, times just 3, over x squared. And that just equals negative 3 over x squared, right? And then with this, I can simplify this down to negative 3 times 1 over x squared. Now look at this. Oh, equals du over dx. Boom. Look at this. It matches up with the x squared down there. So what I do is I multiply dx over to here, and then I divide, and then I divide negative 3 over to here. So I should get I should get 1 over x squared dx equals negative 1/3 du. Boom. So now I simplify, I don't simplify, I rewrite this. So I get 3, 1, e to the u, because I used u for 3 over x, times 1 over x squared dx. Boom. And with knowing this knowledge over here, I can substitute these two right here for d of u, du, and make the 1/3 out here because it's a constant. The negative 1/3, put it outside of it because it's constant. So that equals negative 1/3 the integral of now I do e to the power u, and du. Now I don't know this top one and bottom one yet because this is the d of u equation, not the d of x. So when I plug in 3 for the u equation, I get 1 for the top. And then when I plug in 1 to the u equation, as x, I get 3. So they just kind of flipped around. Nice and easy. And then next up, we put the 1 in for e, and you multiply that by 1/3. And because I know I'm using e, it's going to be an ugly number, so I'm just going to make it nice and simple for right now, right? So it's going to be e to the power of 1 over 3 minus, and then e to the power of 3 over 3 negative. But because these are both negative, I can add them together. So instead of doing that, instead of doing that, I can just plus. That's an ugly e. And then now I see common factors. I see e's in all of them and 3. So I can come over here and say e over 3 times e squared, because e squared times e is e cubed, over 3. Oops, I don't want to do that. E squared minus 1, because it needs to be negative right there, not positive. And that is my answer for 81.